Okay, I am Dr. Babu, Professor and the Head of the Department of Biomedical Engineering, Sai Sanmuga College of Engineering and Technology, Pullipalayam, Salem district. Today I am going to explain about the title Digital Electronics and Integrated Circuits. Okay. First, we can go to what is digital electronics. In digital electronics, before explaining about the digital electronics, we have to understand about the what is electrical, what is electronics, what are the differences between electrical and electronics. Electrical is flow of electrons in the conductor, that is electrical. Electronics is flow of electrons in the semiconductor and vacuum tubes, that is the electronics. So the difference between electrical and electronics, both are flowing. Electronics flow in the conductor. If the electrons are flowing in conductor, it is called electrical, and semiconductor and vacuum tubes, the same electrons flowing in the semiconductor and the vacuum tubes, it is called electronics. Okay, in electronics we are having types of electronics, that is analog and digital. What is analog signal? What is analog electronics? Like that, what is digital and digital electronics? Analog is the variables is keep on varying with respect to time. For example, voltage. The voltage level is keep on increasing or decreasing or varying with respect to time is called analog signal. So the electronics which deals with analog electronics is analog electronics. And digital, digit means zeros and one. It is not continuous one. It is a sequence. It is digital. So generally binary we are having zeros and one. The 0 is considered as one digit and 1 is another digit. So because of the digit, the name comes digital. So that is the electronics which deals in the digital, that is digit, is called digital electronics. Okay, what is digital electronics? Digital electronics is that branch of electronics which deals with the digital signals to perform various tasks and meet various requirements. It is based upon the digital design methodologies and consists of digital circuits, ICs, that is integrated circuits, and logic gates. It uses only binary digits, that is zeros and ones. Next, in this diagram you can see this is a vacuum tube. This is the diode and this is the transistor, this integrated circuit, which explains about the analog electronics and the digital electronics. It is the vacuum tube, electrons are flowing in the vacuum tube. So what is vacuum tube? It is having the electrode, a large bulb made up of the glass. Electrodes are inside available and only connecting pins are available outside. The size is equal to very large. Once upon a time we are using the vacuum tube. That is, in 1930s, the prototype of the computer were constructed from the mechanical switches, that is called vacuum tubes, and the relays. Okay, after that, these are all comparatively slow when compared to the other technology. Very slow, very large, and produces a great deal of heat. Okay, it produces the large. These are the disadvantage in the vacuum tube. So after that, the technology develops. It comes to the semiconductor. The size will be p-n junction, p-type material and n-type material joining to the called p-n junction. So by using the p-n junction or p-type material, n-type material, we are manufacturing the diode, transistor, like that. These are the semiconducting devices. So instead of the vacuum tube, now we are having diode, transistor as shown in the diagram, The size are very small when compared to the vacuum tube, and also the current consuming is very less, heat produced also very less, so lot of advantage. Even after the development of the integrated circuit, more number of transistors can be fabricated in a single chip called silicon chip. That is called integrated circuit. In terms of hundreds of transistors, many electronic components can be fabricated within a small chip. That is called integrated circuit. Next, need of digital electronics. Okay, already we have seen analog electronics and digital electronics. Okay, what is the need of digital electronics? Okay, comparatively, the reproducibility of the results are good in the digital electronics. Design is very easy, and digital design is logical. We are having more flexible and more functionality in digital electronics. It is easy programmable or programmability, fast, comparatively fast, low cost, that is economical, steady and advancing technology. So that's why we are using the digital electronics. So while we are studying about the digital electronics, first we have to know about the number systems. So number system, we are having different kinds of number systems. The most common number systems are decimal, binary, octal, hexadecimal. So decimal is equal to, in the diagram you can see decimal 537, binary 1010 like that, octal 148, hexadecimal 4BAF. So to avoid confusion, the base of the number shows the what kind of number it is. If it is 10, decimal, if it is 2, binary, if it is 8, octal, and 16 is equal to hexadecimal. So it uses the base number uses, avoiding the confusion while using the different numerical system. The base of each individual number may be as specified by the writing it as a script of the number. Okay, the next we have to know about the logic gates to know about the fundamentals in digital electronics. Okay, logic gates are the basic blocks of the digital circuit. Okay, right side you can say AND gate, OR gate, NOT gate, like that we are having different gates, and these are the input, these are the output. So these are the basic blocks of the digital circuit. There are basic gates, 3 types of basic gates, AND, OR and NOT gate. 2 universal gates are made, that is by using the 3 basic gates. Okay, universal gates are made, which are NAND gate and NOR gate. These gates are the basic functional blocks of the digital circuits, which work upon making combinations of zeros and ones. That is why it is digital. These are the subcomponents of the integrated circuits. Okay, now we can see the different types of the symbols for the gates. First one is, this is the OR gate, this is the NOR gate. So there is a small bubble in the end of this OR gate. So this is the difference between OR gate and NOR gate. Like that, AND gate, NAND gate, the small bubble. We are connecting the small bubble here. And the XOR gate, X-NOR gate, this is the buffer, and this is NOT gate. So these are the some basic blocks. This AND gate, OR gate, XOR gate, X-NOR gate, NAND gate. Like this we are having the different types of the gates. Okay, now we can see one by one logic diagram symbol. So this is the logic diagram symbol for the NOT gate. That is, the input is given. This is the truth table. Okay, in this diagram we have explained about the Boolean expression, logic diagram symbol and truth table. If we know the truth table, we can get the Boolean expression, or if we know the functionality of the NOT gate, then we can get the Boolean expression. Okay, the input is given, then the output is equal to x dash is equal to a dash. That is 0, output is equal to 1. If the 1 is equal to input, output is equal to 0. So that's why x is equal to a dash. Okay, is a truth table. The input a and x is equal to output. If the input is equal to 0, output is equal to 1. If the input is equal to 1, output is equal to 0. This is the truth table of the NOT gate. Boolean expression. Then x is equal to logic diagram symbol. This is for the AND gate. We are having two inputs a and b, and the output is equal to x. Okay, x is equal to, that is output is equal to a dot b. This is the Boolean expression. Okay, now this is the truth table. In the AND gate, if the two inputs are 1, we are getting the output. Okay, otherwise if any one of the input is equal to 0, and we are not able to get the output, that is output is equal to 0. That's why 0, 0, the output is equal to 0. 0, 1, output is equal to 0. 1, 0, output is equal to 0. If both inputs are 1, 1, it is set, it is output is equal to 1. So 0 is equal to reset, 1 is equal to set. If the both inputs are set, then output is set. If any one of the input is not set, then output is equal to 0. That is the reset. Okay, like that we are going for the OR gate. OR gate, if any one of the, so Boolean expression x is equal to a plus b. So if any one of the input is equal to 1, that is 0, 1, 1, 1, 0, 1, 1, 1, 1, that is 0, 0, 0. Just like it is Boolean addition, logical addition. Then logic diagram symbol for the NAND gate, just opposite to the AND gate. Okay, here in NAND gate, if both inputs are set, output is equal to set, otherwise output is reset. Here the both inputs are 0, then we can get 1, otherwise it is 0. So we can come to the truth table. 0, 0, 1. If both inputs are 0, we are getting 1. Okay, then 0, 1 we are having 1, 1, 0 we are having 1, and 1, 1, 0. Okay, now we can compare with the AND gate truth table. Wherever we are getting 0, here we are getting 1. Wherever we are getting 1, we are getting the 0. Okay, just like that we can go for the NOR gate. It is opposite to the OR gate. So in OR gate, wherever we are getting 0, it is 1, and 1 we are getting the 0. So like this we are having the Boolean expression, logic diagram, and truth table to explain about these logic gates. Using this logic gate, we can get a circuit. We can make a different kinds of circuit to get the defined specific output. That depends upon our aim or our problem. Okay, next we can go for the combinational logic circuits. Combinational circuits or combinational logic circuit. So here, by using the gates, it may be AND gate, OR gate, NAND gate, NAND gate, OR gate, like that, we can combine the gates. That depends upon that we are getting the output. The digital logic circuits whose outputs can be determined using the logic function of the current state input or combinational logic circuits. Here one example for the logic circuits. So AND gate, the output of the AND gate is connected to the OR gate. Okay, this is the one example for the combinational circuit. Okay, some of the examples of the combinational circuits are adder, subtractor, decoder, encoder, multiplexer, demultiplexer. Okay, adder, subtractor, decoder, encoder, multiplexer, demultiplexer. Like that we are having the different kinds of combinational circuits. Next we can come to the future scope of the digital electronics. What is the future scope? The digital electronics uses VLSI technology, which has considerably decreased the size and the area of the circuit boards and has enhance the accuracy and the performance of the systems. Moreover, digital systems have the advantage of data encryption for the communication purposes. The data transmission is very safe and secure. All these factors clearly show that the digital electronic stream has wide feature scope in the modern era. Then we can come to the integrated circuits. Integrated circuits are popularly known as silicon chip or computer chip or microchip. ICs are the tiny electronic circuit used to perform the several operations like amplifier, timer, counter, oscillator, microcontroller or a computer memory. It is formed as a single unit by diffusing impurities into the single crystal silicon, which then serves as a semiconductor material. Upon the ICs, there are several active and passive components. Active components like transistor, diode, passive components like resistors and capacitors. Okay, these integrated circuits, SSI, small scale integration, MSI, medium scale integration, LSI, logical integration, VLSI, very large scale integration, ULSI, ultra large scale integration. Okay, that depends upon the number of transistors and the other electronic components they contain. If 100 electronic components, it is SSI. Okay, if 100 electronic components is SSI, 100 to 3000 components MSI, 3000 to 1 lakh it is LSI, 1 lakh to 10 lakh it is VLSI. Like that depends upon the number of components we are having. SSI, MSI, LSI, ULSI, VLSI, ULSI, like that. It is called integrated circuit. Okay, advantage: extremely small size, small weight, very low cost, reliable, low power consumption, easy replacement, increasing operating speed, improved functional performance, greater ability of operating at extreme temperatures, suitable for small operation, no component project above the chip surface in an AC, as all the components are formed within the chip. Thank you.